So coming from chemical engineering background, I always wanted to bridge my process knowledge with data analytics. This SCADA extractive batch distillation project was the perfect opportunity to apply Python, SQL, Power BI to real chemical plant. Extractive batch distillation is widely used in the plant to purify the ethanol and similar chemicals, but plants often struggle with inconsistent purity and yield across the batches. My goal was to uncover the with the actionable insights that help to stabilize and optimize the performance. So I combined equipment equipment information, sensor readings, and lab results. I joined raw SCADA time series reading with equipment metadata and final batch lab result. This gave me the complete view from the process operations to product quality. This gave me the complete view from process operations to product quality. I filtered the batch cycle and relevant sensors, summarized trends, and built this clear dashboard. So I cleaned data using NumPy and Pandas, using linear interpolation and forward fill and backward fill for age values. Then I detected and handled outliers using z-score. Tools that I used for batch-wise comparison and product purity. Sensor trends across the shifts and batches. I used SQL for data joins, filtering, and summarization. Python, NumPy, Pandas for cleaning and trend calculations, and Power BI for storytelling and dashboard. What dashboard reveals is batch-wise comparison of the product purity and yield, sensor trends across shifts and batches, and batch 4003 is the batch which gives the highest product purity and yield. That is uh, that is 93, almost 93% product purity and 98% yield. So I identified the low yield causes of for other batches by analyzing the reflux ratio, reboiler temperature, and shutdown timing. So done that using pandas, and here are the results. So this is the final result. It shows the which factor affects the most on the product purity and yield. So this clearly indicates that solvent flow is strongly positive with purity plus 0.76. This makes sense that more selective solvent can improve the separation. So This project analyzing shift-wise and sensor-wise trends showed that the higher reflux ratio maintained purity but lowered the yield for batch 4002. Operators can adjust the reflux ratio and runtime to balance these KPIs, aiming for the batch 4003's performance. That is this batch 4003's performance. So this project strengthened my practical data wrangling, visualization, storytelling skills, and proved how data driven decisions can boost chemical process efficiency. It was deeply satisfying to connect my core chemical engineering knowledge with my evolving data analytics skills. This project reinforced my passion for combining domain knowledge with data insights. Excited to take this further and help the plants run more efficiently. Thank you.